Group number 3. Experiment number 5. Types of chemical reactions and factors affecting the rates of chemical reactions. Good afternoon. Number 1. Introduction. Chemical reactions can be classified into 4 types. 1. Direct union or combination. Number 2. Decomposition. Number 3. Single displacement. And number 4. Double displacement. Four types of chemical reaction. Number 1. Direct union or combination. A synthesis reaction or direct combination reaction is one of the most common types of chemical reaction. In a synthesis reaction, two or more chemical species combine to form a more complex product. A plus B is AB. In this form, a synthesis reaction is easy to recognize because you have more reactants than products. A chemical reaction in which two simple substances combine to form a complex substance is called a direct combination or direct union. For example, it is represented by direct combination reaction is a fusion reaction as there is a fusion of two or more simple substances.
And for the second type of reaction, we have decomposition. So decomposition is the breakdown or change of a material or substance by heat, chemical reaction, or other processes into other chemical compounds. Thermal decomposition is decomposition initiated by heat. So this type of reaction, we are actually applying heat. For example, we have A and B as our element AB. And if we will apply the composition reaction, it will split into two compounds. So AB will be A and B. And for the single displacement, a single displacement is a chemical reaction where one reactant is exchanged for one ion of a second reactant. It is also known as single replacement reaction. Single displacement reaction takes the form A plus BC, and if single displacement acts, it will be B plus AC. For example, we have here in the illustration the man that is wearing something orange and the girl in the white plus the girl with the green. And if single replacement takes action, the man with the orange clothes will be partnered with the woman who is wearing the green clothes plus the woman in the white clothes. So to sum it all up, single replacement is AB plus C and is equal to ACB.
Learning outcomes. The student should have 1. Observe some types of reaction. 2. Identify the products of this reaction. 3. Identify the different factors that affect the rate of chemical reaction.
Double displacement. Double
Materials.
displacement type of chemical reaction
19 test tube. 10 ml graduated cylinder. Test tube rocks. Spatula. Alcohol lamp. Tester. Rubber gear and
Materials. 19 test tubes, 10 ml, graduated, cylinder test, tube racks, spatula, alcohol lamp, test tube brush, test tube holder, crucible, crucible tongue, beaker, iron stand, thermometer, dropper, rubber tabbing, wire gauze, iron ring. Reagents mg, ribbon, CaCO3, 1M CuSO4, staple wire, 1M FeSO4, Cu wire, 3M HCl, 1M Pb or NO3, 2, 1M K2CrO4, 0.5 m H2SO4, 0.5 m BaCl2, 12 n HCl, mostly zinc, 6 NHCl, disodium phosphate, 3 NHCl, K permanganate, manganese dioxide, BaCl2, mixture, Zn dust, sodium oxalate, H2O2. Procedures. 8 types of chemical reactions. Observe the appearance of the substances before and after every reaction. Note the change that takes place. Identify the types of reaction involved in each case. Number 1. Ignite a small piece of Mg ribbon. Number 2. Combine each of the following substance in separate test tubes. A. 5 ml of 1 MCuSO4 and staple wire. B. 5 ml of 1 MFeSO4 and copper wire. C. 5 ml 3M HCl and copper wire. And 3. In a test tube, add 3 ml 1M K2CrO4 to 3 ml of 1 MPbNO32. And number 4, mix 4 ml of 0.5 m H2SO4 into 4 ml of 0.5 BaCl2.
B. Factors affecting the rate chemical reactions. Observe and describe the speed of the reaction, nature, or reactants. A. In a test tube, add a drop of barium chloride solution to 1 ml of sulfuric acid. B. In another test tube, add a few drops of disodium phosphate solution to 1 ml magnesium mixture in a test tube.
Concentration of reactants. A. Place 5 ml of each concentration of hydrochloride, 12N, 6N, 3N in separate test tubes. B. Add a piece of magnesium ribbon to each test tubes. Temperature. A. Place 10 ml 0.1 m sodium oxalate solution to each test tube. B. Leave test tube 1 at room temperature and test tube 2 at 75 degrees Celsius. C. After heating, treat each tube with 10 ml potassium permanganate oxified with a few drops of dilute sulfuric acid stir.
And as for the effect of surface area on reaction rate, first is to place 5 milliliters of 3M hydrogen chloride to each test tube. Drop mostly zinc to test tube 1 and add a pinch of zinc dust into the test tube 2.
Number 5, presence of a catalyst. First, into 2 separate test tubes, add 2 ml of hydrogen peroxide to each tube. Then, add a pinch of manganese dioxide to one test tube and compare.